Hello everyone. Today our group will be reporting about bucket sort in data structures. We'll explain details you need to know about our topic and help you understand the logic and implementation of bucket sort. We hope that our report will easily help you understand this topic. Let us begin. So what is bucket sort? Bucket sort, also known as bin sort, is a sorting algorithm that works by dividing the elements of arrays into several buckets. Each bucket is then sorted individually using any suitable sorting algorithm. Finally, the sorted buckets are combined to form a final sorted array. Next, I will explain the algorithm used to bucket sort. Step 1 is to create buckets. Create an array of buckets where the number of buckets is typically chosen to be proportional to the number of elements in the input array. Step 2 is distribute the elements. For each element in the input array, determine the appropriate bucket based on the element's value. Assign the element to the corresponding bucket. The third step is to sort the buckets. Sort each bucket individually using any suitable sorting algorithm. This could be a simple sorting algorithm like insertion sort or a more complex sorting algorithm like merge sort. The final step is to combine the buckets. Concatenate the sorted buckets in order to form the final sorted array. The result is an array where the elements are in this ascending or descending order, depending on the sorting algorithm used in step 3. So, why bucket sort? Bucket sort is efficient, especially for sorting data that is evenly distributed across a specific range. It is also versatile when it comes to sorting various data types like integer, string, objects, and many more. It is also a simple sorting algorithm to implement. Bucket sort is well suited for sorting data that is randomly generated because this type of data is commonly distributed evenly across a specific range. A good option for sorting data stored in external memory like databases or files. Now, where to use bucket sort? You can use bucket sort when sorting a list of student IDs, product prices, and IP addresses. Student IDs are typically assigned in a sequential order, so they are likely to be evenly distributed across a specific range. Bucket sort is therefore a good choice for student ID sorting, as it is efficient for sorting evenly distributed data, as I have said before. This is also the case when sorting a list of product prices and a list of IP addresses, as they are both typically distributed across a specific range and are defined by a standard format.
For the efficiency of the algorithm of bucket sort, the bucket sort's time complexity is influenced by the number of buckets and the sorting algorithm applied within each bucket. In the best case scenario, with the time complexity of big O of n, where n is the array's element count, bucket sort excels when the input array exhibits uniform distribution or when the elements range between 0 and 1. For the average case, the time complexity is big O of n plus k, where n is the element count in the input array and k is the number of bucket employed. In the worst case scenario, the time complexity reach big O of n squared, where n is the array's element count. This situation arises when the input array lacks uniform distribution, leading to certain buckets containing substantially more elements than others. Next, optimizing the time complexity of bucket sort. One approach involves employing a diminished number of buckets. While this minimizes the time complexity, associated with sorting elements within each bucket. It concurrently necessitates iterating over a large number of buckets. Another technique is to use a more efficient sorting algorithm to sort the element within each bucket. For example, if the element in each bucket are already sorted, then we can use a constant time algorithm to merge the buckets.
So here's a simple pseudocode for the bucket sort algorithm, and I will explain it further. So this first line, which is the bucket sort parenthesis a parenthesis, this is basically the main function that takes an array A as input and performs the bucket sort. This line declares the beginning of the bucket sort algorithm. It defines a function called bucket sort that expect an array A as input. Next, the second line, which is the n equals length parenthesis A parenthesis. This calculate the length of the input array A and it store in the variable n. Here, the variable n. Here, the length of the input array A is calculated using the length function, and the result is stored in the variable n. Knowing the length of the array is essential for later iteration and calculations. Third, this is the third line for this pseudocode. The buckets equal create underscore empty underscore buckets parenthesis. So this create an array of empty buckets. This specific implementation of create underscore empty underscore buckets parenthesis depends on the programming language, but initially it initializes an array or a data structure to hold the bucket. So this line creates an array called buckets to store the buckets. The function create underscore empty underscore buckets parenthesis is called to initialize an empty buckets for each possible index. The actual implementation may vary depending on the programming language, but essentially sets up the data structure to hold the buckets. Fourth line, which is the for loop, for I equals 1 to n. So this iterates over each element in the input array. This line initiates a loop that iterates over each element in array A from the first element to the last. The loop variable I here represent the current index in the array. Next, the fifth line, which is to calculate the index. So this calculates the index of the bucket for the current element A. AI here. This step is essential for the distributing the elements across the buckets. For each element in the array, this line calculates the index of the bucket where the element will be placed. The floor function here, the floor function ensures that the result is an integer. Next, this line, the insert AI into buckets index. So this insert the current element AI into the appropriate bucket determined by the calculated index. So the current element AI is inserted into the buckets here, determined by the previously calculated index. This step is a part of the scattering phase, where elements are distributed into the bucket based on their calculated indices. Next, for the sort part of this pseudocode here. So, this line, the for I equals 1 to length buckets, this iterate over each bucket in the array of buckets. This is another loop that is initiated to iterate over each bucket in the array of buckets. Next, this sort parenthesis buckets I parenthesis, it sort each non-empty bucket. Then the sorting algorithm used here depends on the specific implementation. You can use another sorting algorithm such as insertion sort or quicksort. For each non-empty bucket, the element within the bucket are sorted. The specific sorting algorithm used may vary depending on the implementation. Common choices include insertion sort, quicksort, or any other efficient sorting algorithm. This line next is to concatenate. So the result equals concatenate underscore buckets, buckets, parenthesis. So basically this concatenate the sorted buckets to obtain the final sorted array. So this line concatenates the sorted buckets to obtain the final sorted array. The order of concatenation is based on the order of the bucket indices. Lastly, the return result. So this returned the sorted array as the output of the bucket sort algorithm. Finally, the sorted array is returned as the output of the bucket sort function. This array contains all the elements of the input array sorted in ascending order. That's all for the pseudocode of bucket sort.
So hi guys, my name is Mark Christian Alisansi Federer and I am tasked to present and report the sample code and implementation in our Gaussian sorting method, which is the bucket sort. Now this part right here, this function right here just display the elements as for the step-by-step process on how the sorting works. It takes a 2D vector buckets as input, representing the buckets in the algorithm, and iterates through each bucket, displaying the elements within each bucket. Now for the main function, which is the bucket sort. The bucket sort function implements the algorithm. It takes an array R and bucket size as input. The function first finds the minimum and maximum value in the array, then calculates the number of buckets needed based on the range of values and the bucket size. It then initializes a 2D vector bucket which distributes the elements of the input array into the appropriate buckets based on their values. And after distributing, it prints the initial contents of the bucket. It then proceeds to clear the original array, then sorts the individual bucket using the sort function from the algorithm library in C++. After the sorting method, it then reconstructs the original array by pushing the sorted elements from the bucket, printing the contents of the buckets after each sorting operation. Now, for the detailed explanation of the bucket sort, the empty this part right here checks and ensures that the function does not attempt to sort an empty array, avoiding any unnecessary computation. This part right here takes to the array to find the minimum and maximum values, enabling the calculation of range of elements. This part right here does calculate the number of buckets needed to cover the range of values based on the specified bucket size. The bucket count is determined by dividing the range of values by the bucket size and adding 1 to ensure all elements are covered. Now this one. Now this is initializes the 2D vector bucket to store the elements in different buckets. And the elements from the input array are distributed into the appropriate buckets based on their values using a formula that considers the minimum value and the bucket size. And it prints the initial buckets, providing a clear visualization of how the elements are distributed across different buckets before any sorting operations occur. Then after sorting, it displays the contents of the bucket, demonstrating how the elements are sorted within each bucket and providing a visual representation of the sorting process. And the function clears the original array to prepare for the sorted element. It then iterates through each bucket, sorting the elements using the standard library function and reconstructing the original array by pushing the sorted elements back into it. Now, the main function is where the program begins. It prompts the user to input the number of elements and the elements themselves, which are stored in a vector called R. Now, and then it prompts the user to input the bucket size. Then the bucket sort function is called with the R and bucket size as arguments to perform the sorting algorithm. After the process is completed, the sorted array is now printed to the console. Now, just like this, I'm going to do a sample implementation. Now I'll enter 10 elements with the elements as 1, 2, 4, 5, 6, 7, 8, 9, 10. Then my bucket size will be 3. This is my output after doing it. Now let me explain it first. The input phase is prompted to enter the number of elements, the elements themselves, and then bucket size. The input array and the specified bucket size are crucial for the subsequent steps of the algorithm. Then, for the bucket initialization and distribution, the algorithm initializes the buckets and distributes the elements into different buckets based on their values, such as this. Then each element is placed into the appropriate bucket using a formula that considers the minimum value and the bucket size. Then the sorting phase, which is this part right here, sorts each individual bucket using the standard library sort function. And after the sorting operation, the contents of the buckets are updated to reflect the sorted elements within each bucket, such as this. Now this is the sorted array now using the bucket sort. This is the process of the sorting algorithm that we chose, which is the bucket sort. Now, final sorted array. The algorithm reconstructs the original array by pushing the sorted elements from the buckets back into the array. The process continues until all elements are sorted, leading to the final sorted array output. Then the algorithm works by efficiently distributing elements into different buckets based on their values, sorting the elements with each bucket, and reconstructing the original array by combining the sorted elements from all the buckets. This process ensures that the final array is sorted in ascending order. So, this code that I did was to sort the numbers in ascending order. Now, and so there. Thank you for listening and hope you learned a lot. Thank you.